Okay, so hello everyone. My name is Rohit Prat and this is live session 7. So today we will discuss about interpolation. So today there will be no coding Matlab. Today there will be only theory. So let's start with question number 1. So here a data set is given. This is X and this is F. So the question is we need to construct the difference table. So let's do question. Let's solve the question. Okay, so here we have one, 2, 3, 4, 5, 6. Total six, total six data points. So the maximum polynomial we can get of fifth order. Okay, so all the points are equispaced, so we can use the Newton's forward difference technique. So delta f equal to f(I) plus 1 minus f of I. That means one. So this will be 4. So I am taking the difference of this first two element minus. So it is minus 4 plus 8. So it is plus 4. Okay. It will be 10. It is 19. It is 63 minus 25 is 38. 38. And 129 minus 63 is 66. Now, now this is the this is delta square f. Delta square f will be 6, 9, 19. 38 minus 66 is 20. Now delta cube f will be 3, 10, and 28 minus 19 is 9. Delta to the power 4f, it will be 7 and minus 1. And the last one, delta to the power 5f. It will be minus 1 minus 7, it is minus 8. So this is the table for this data set. Now the second question is related to question 1. So we need to develop a fitting polynomial px with x not equal to 2, x1 equal to 4, and x2 equal to 6, and we need to estimate the error. Okay, so first let us do the first part where x not equal to 2, x1. So let's start with finding the polynomial for these three data points. So for these three data points we have. So, what will be the formula? So, p of x. So we need to consider this one. Okay. 2, 1, 6. Just a moment. So it will be f of x naught plus x minus x naught by h to delta f naught plus x minus x naught x minus x1 by factorial to h square delta square of f naught. Now remember this is coming from this formula. So f of x naught plus ph, huh, where x naught plus ph equal to x, which implies p equal to x minus x naught by h. So if we expand in using the Taylor series approximation, so it will be f of x naught plus p into delta f naught plus p into p minus 1 by factorial 2 delta square f naught plus dot dot dot. Now if I, so I am here I have just, so here I have just substituted the value of p in this term. So I will finally get this function. So here my h is the step size, h equal to 2, h equal to 2, and then px will be, what is the f of x naught? F of x naught is minus 8. So I have considered this as my x naught 2. Okay, so it will be minus 8 plus x minus x naught by 2 into delta of f naught. Delta of f naught is 4 plus x minus x naught, x minus x1 by h squared is 4 multiplied by 2, that will be 8. Delta square f naught is 6. So this will be the polynomial, right? Now we need to estimate the error. Okay, suppose error is the ex, and expression for ex is, it will be x minus x naught, x minus x1, x minus dot 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 x minus of xn divided by n plus 1 factorial f to the power n plus 1 psi, where psi is some intermediate point. Okay, and it can be approximated as n plus 1. So this way you will, so you need to put the value, and this way you can calculate the expression of the error. Okay, now let us, so now the second part of the question, the, sorry, this is a different question, it is also related to question 1, which says that if, so here, so previously I had 3 data points. So previously the previous polynomial is of order 2, that is a quadratic polynomial. Now I need to find a cubic polynomial this time. Okay, so let's solve the question. Just a second. So again, use the formula. So here I am using the alternate formula, that is f of x naught plus p into delta f naught, p into p minus 1 by factorial 2 delta square f naught plus p into p minus 1 p minus 2 by factorial 3 delta cube f naught. So this is a, so there are 4 data points. So so n plus 1 equal to 4. Okay, so n equal to 3, that is the order of polynomial, and the maximum we can get in terms of delta, that will be delta to the power n f naught, that is here it will be delta cube of f naught. Okay, so now let's substitute the value. So or alternatively we can do what? So we can do, so if I name this as p2x because it is a second order polynomial, I can just write p2x plus, we have already got p2x, p into p minus 1 p minus 2 by 6 into delta cube of f naught. Now what is the value of p here? We know, equal to x minus x naught by 8. So x minus x naught, what is x naught here? X naught here is 2. X minus 2 by h. So h is again 2. Alright, so it will be p2x plus x minus 2 by 2, x minus 4 by 2, and x minus 6 by 2. divided by 6, and delta cube f naught, delta cube f naught is 3 multiplied by 3. So this will be your desired answer. So you need to calculate it, but this is the answer. Now, again, the same problem. This is the example of shifted Newton's forward difference formula. Previously, my x naught was 2, so x1 was 4 and x2 was 6. Here I am starting with here it is defined as x naught equal to 6. So we have to shift the formula. Okay. So from the table, this time this is your x naught. This is the expression of your x naught. Okay. So this will be your f naught. This will be your delta f naught. This will be your delta square f naught. Okay. And let us find the formula for that. So px, again this is the p2x. Okay, so it will be f of x naught plus p into delta f naught plus p into p minus 1 by factorial to delta square of f. That's it. So what is the value of f of x naught? Oh, that means what is the value of f at x is x naught equal to 6, and the value is 6 plus p is x minus 2 by 2. So x minus 2 by 2 into delta of f naught. Sorry. So this is a mistake. This time it will be 6 because the formula of p is x minus x naught by h. Now my x naught is shifted. X naught is no longer 2. It is 6. Okay, so it will be x minus 6 by 2. Okay, multiply into delta of f naught. What is delta of f naught? Delta of f naught is 19 plus x minus 6 by 2, that is p, into p minus 1. So p minus 1 equal to x minus 6 by 2 minus 1. So x minus 8 by 2. X minus 8 by 2. And there is 1 by factorial 2. That is 1 by 2. It will be multiplied by delta square of f naught. What is delta square f naught here? Yeah. So this is again 19. Should not be 19. Yeah. So this okay. Just a moment. Yeah, so I'm taking the value 19 into 90. So if you expand this and find a formula, you will get your desired P2x starting from x naught equal to 6. Okay, so this is a shifted Newton's forward difference formula. You just need to change the definition of x naught, and the rest of the procedure is exactly the same. Now, okay. So now here you are given your values of x, and the value of cos of hx is given here. So what is cos x? It is e to the power x plus e to the power minus x divided by 2. This is cos of x. Okay, this is the hyperbolic function, hyperbolic cosine. Now you need to find the value at x equal to 0.56. Okay, so the procedure is exactly same. First you need to build the table, and then you need to do the calculation. So let us build the table. So here there are 4 data points. That means the order of polynomial will be 3. So that means maximum we can get delta cube of f naught. So x, and I am naming this as y. Okay, y. Right. 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 So first let us find the value of p first. Okay. So p equal to x minus x naught divided by h. Here your x is 0.56, 0.56, and x naught is 0.5. I am defining this as my x naught. zero point 0.5 divided by 0.1. This is the h. So what is the value? Let's use calculator for that. Okay. So my term is 0.56 minus zero point 0.5 by zero point 0.1. So the value is 0.6. This is the value of p. Okay. So let's store that for a while. Now let us build the table first. So 0.5, 0.6, 0.7, 0.8. Okay, so the value is 1.127626. I need to modify the table because I need a larger space now. 1.127626. 1.125465. 1.255169. 1.337435. Now delta y equal to, this is the forward difference, y plus 1 minus yi. Okay, so let us calculate that. Okay. So the first term is 1.127626 minus 1.185465. So this term is minus 0.057839. The second term will be 1. I have made a mistake. It will be plus. Okay. Second term will be 1.255169 minus 1.185465. So this will be 0.069704, and between 0.8 and 0.7 this term will be 1.337435 minus 1.255169. So it is 0.082266. Now I need to calculate delta square of y. So the delta, okay, so this term I have calculated, it will be 0.012562, and this will be 0.069704 minus 0.057839. So this term is 0.011865, and there will be the last term delta cube y. 0.01562. So this term is 0.000697. Okay, so this is the table, the difference table. Now I need to calculate what is y at 0.56. Okay, so y at x naught plus ph equal to y naught plus p into delta y naught plus p into p minus 1 by factorial 2 delta square of y naught plus p into p minus 1 p minus 2 by factorial 3 delta q of y naught. Alright. So, so let us do this calculation. So the first term is 1.127626. P is 0.6, 0.6 into 0.057839 plus. So this is 1 by 2 into 0.6 into t minus 1, that is minus 0.4, minus 0.4, and your delta square y naught is 0.011865 plus 1 by 6 into 0.6 into minus 0.4, and it is, so this is, so what is 0.6 minus 2, that is minus 1.4, right? It is minus 1.4 into delta q y naught is 0.000697. Okay, so let's calculate this again. This is a long calculation. So what is the result? 1.127626 plus zero point 0.6 into 0.057839 plus 0.5 into 0.6 into minus 0.4 into 0.011865 plus 1 by 6 multiplied by 0.6 multiplied by 0.4 into 1.4, because minus minus it will be plus finally, into 0.000697. So the final answer that I am getting, kindly check it yourself. The final answer I am getting, I am writing it here. It is 1.16094463. Okay. Now, if you check in calculator, if you check in the expression of cos of h, so I am writing the correct analytical expression because this is an approximation, right? The correct analytical expression of cos of h 0.56 is equal to 1.16094078.2. So you can see that this number and this number are very close to each other, so the approximation is correct. Okay, right. Now let us do another problem. So we need to solve it using, so J0x. J0x is similar to sin x or cosine x. Okay, but this is in the cylindrical geometry. Okay, like the sin x or cosine x. Suppose this is your sin x function, a oscillatory function. Similarly, your cos x is also an oscillatory function, and J naught x. So this is in the Cartesian geometry. This is your x and this is your y. But your J naught x, I am I am drawing the car. So this is your radial coordinate. Okay, this is your r direction. Remember that unlike the Cartesian coordinate, the radial direction always increases. This is 0 and this is 1. This is because this is a symmetry, the rotational symmetry. Okay, actually this is on a cylinder. Okay, I and this is the plot, 0 to some r. Okay, and your J naught x looks something like this. This is a similar to the cosine or the sine function in the Cartesian coordinate. Okay, an oscillatory function. We just need this. We don't need this in the detail of J naught x. We just need to calculate the value. But this is the basic idea of J naught x. Okay, so for clarity, J naught, this is called Bessel function, and this zero and Bessel function of order zero. Okay, this zero indicate that. All right, fast kind. You don't need to, you just need to remember this Bessel function thing. Other things are fine. Now I need to. I think I should keep those here. I am keeping these images here, but I need to calculate the value of x and J naught of x. Okay. So okay. So how to do that? Okay. So one thing I can do, I will let me just copy these images and I will paste it at the end of those pages. Just, uh, I will just copy the. I will just dump this thing here. Okay. So, so I'm writing. So this is related to question. Also, what was the question number? I think it is question number 5. Question 5. Okay. This is sine or cosine, and this is what the Bessel function. Chain. Okay. Okay. Now I can write the table here. So remember here I need to do two things. One is first I have to use the forward difference, and then I need to use the backward method. Okay. So it's so again I am writing this not at J0 at Y. So 1.7, 1.8, 1.9 and 2.0. So the first what is the first thing? First thing is I need to calculate the value of P. So P is so I am considering this as my x naught. Okay. So P equal to x minus x naught divided by h. So 1.72 minus 1.7 divided by 0.1. So what will be the value? 1.72 minus 1.7 by 0.1. 0.1. So the value is 0.2. Okay. Now we are all set. Now I can construct a different step. Okay. Right. So what will be the y? It is 0.3979849, 0.3399864, 0.2818186, 0.2238908. Okay. Just a moment. Okay, so what is the value of the delta y? The first term. So 0.3399864 minus 0.3979849. So this is the first term. So this will be minus 0.0579985. The second term is 0.28186 minus 0.3399864. So this is minus 0.0581678, and then 0.2238908 minus 0.281886. This is also equals minus 0.05799278. Then let us calculate delta square y plus this. So let us first calculate the last term. So this is plus 0.0581678. So this term will be 0.00024, and this term will be 0.57995 minus 0.51678. This term is minus 0.000169 and finally delta cube y is this term plus this term. So 0.0004. This is 0.000409 of 3. So now the value of J0 is just a second. So what will be the value of at 1.72? So y at 1.72 is equal to y0 plus p into delta y0 p into p minus 1 by factorial 2 delta square y0 plus p into p minus 1 p minus 2 by factorial 3 times delta cube of y0. Okay, and okay, so let us find a value. So what is y naught? Y naught is 0.3979849. So from the trend we can see that at 1.72 it will be smaller. It will be smaller than this value. Okay, so finally we should get a smaller value compared to this. Plus p is your 0.2 into delta of y naught, that is minus 0.05799985 plus 0.2 into 0.2 minus 1, that is minus 0.8 divided by 2 into delta square of y naught, and delta square of y naught is again a negative sign minus 0.0001693 plus 0.2 into minus 0.8 into minus 1.8 divided by 6 into 0.0004093. So if you do that, you will get the corresponding final answers. Okay, so just do the calculation, and you will find that the vector j0 at 1.72 will be less than at j0 1.7, because from the trend we can see that as x increases, the j0 value of j0 decreases. Finally finish the calculation. Now, so I will tell about what will happen in the backward method. Okay, so in case of backward method, what will happen? So remember that for the backward method, the formula is grad of y. So y, this y, Matlab y equal to yi minus 1. So this is the formula. Now, so in that case, you will start from here. So this will be your corresponding x0, and all the and the table is already constructed. Okay. So this is your y0. This is your y0. This term is your y0, and this will be your cube of y0. Okay. So only difference, the only change will happen in the value of p, because this time the value of p will be different. Here your x is 1.72, but your x naught is your 2.0. H will remain as constant. Okay, but you don't need to construct a table again, because you have already constructed it. See that if you define at y0, this will be your nabla of y0. Okay, this will be a nabla square y0, and this will be a nabla cube of y0, right? Because if this is y0, then this term minus this term will be this term, right? Again, this term minus this term will be this term, and finally this term minus this term will get this nabla cube of y0. So your value is already constructed. The table is already constructed. You just need to change the definition of p here. Change the x, change the x naught, and your h will remain as constant. And kindly do the calculation. You will find that from the forward method and from the backward method, you will get exactly the same answer. Okay. So let us move on to the next question, the question number 7. So, yeah. So what is question number 7? So consider a set of data points having the form xi, yi, where I is, so it is very, so there are n data points. Okay. Now in case of n data points, we can get the exact polynomial of n minus 1th order. Okay, so if I have, so here in the previous example, we have seen that if I have 4 data points, I can construct a polynomial which has the order of which is of third order. I can construct a cubic polynomial. Okay, so here we can build an exact n minus 1th order polynomial. Okay. Now, which of the following option hold good for an nth degree of interpolating polynomial? But in the question, it says that the polynomial is at nth degree polynomial, not the nth minus 1th degree polynomial. So that this polynomial cannot be an exact. Okay. So there will be an infinite number of interpolating polynomial we can construct from the data set. So this option C will be the correct option. Okay. Now we can questions from the forward difference. So I need to calculate the value of delta of tan inverse x. Okay. So what is the formula? Delta of f of x is equal to f of x plus h minus of fx. So here f of x is tan inverse x. So it is tan inverse x plus h minus tan inverse h. So this is simply a school level trigonometry problem. So tan inverse a plus tan inverse of b is equal to tan inverse of a minus b divided by 1 plus a b. So this is the correct formula. So this is the formula for that. So so now in this case, what will be the situation? So here this is a minus. Okay. So it will so here it will be tan inverse of x plus h. So instead of plus here, so instead of minus, it will be a plus here, plus x, and here it will be a minus. So 1 minus x into x plus h. So it is tan inverse of h plus 2x, 1 minus x square minus x. So this is the formula. So this will be your answer. Okay. Now the second part, that is this exercise is similar to this one. First, I need to calculate delta of f of x. So it will be again f of x plus h minus f of x. So it will be e to the power 3 times x plus h. Remember that e to the 5 is a constant. Okay. So plus 5 minus e to the power of 3x plus 5. So I can take e to the power 5 as common. So I can take e to the power 3x plus 5 as common. I will finally get e to the power 3h minus 1. Again, delta square of fx. Okay. Now let us give this the name gx is equal to delta of gx equal to g of x plus h minus gx, which means so the h will be added with x, so it will be e to the power 3 into x plus h plus 5 multiplied by e to the power 3h minus 1 minus this term e to the power 3x plus 5 e to the power 3h minus 1. So I can take very easily e to the power 3x. So first let us take the common e to the power 3h plus 1, 3 e to the power 3h minus 1. So I will be left to it e to the power 3 times x plus h plus 5 minus e to the power 3x plus 5. So I can again, I think I can take some, so there are some common factor as well. So e to the power 3x plus 5, yeah. E to the power 3x plus 5 is a common factor. So it will be then e to the power 3h minus 1. So the final answer is e to the power 3x plus 5 e to the power 3h minus 1 whole square. Okay. So this is your answer. So you can see the pattern here. So delta of f is e to the power 3x plus 5 e to the power 3h minus 1. Delta square is 3h minus 1 square. So that we can conclude that it will be delta to the power n it will be e to the power 3x plus 5 e to the power 3h minus 1. Okay. Now let's solve the next question. Right. So in the lecture, so what will be the for a polynomial? So if I have delta, so what will be delta to the power n, x to the power n? Let's solve this. Okay. Suppose uh, let us do for a simple case n equal to 2. Okay, then I will solve this question because this question is related to this solution. So I need to find delta square of x. So first I need to do delta square, delta of x square. So delta of x square is equal to x plus h whole square minus x square. So the answer is 2hx plus h square, right? So now delta square of x square. So here h will be added with x. the 2h times x plus h square minus 2hx minus h square. So this term will be 2 times h square. If we do the calculation, I will get this percent. Okay. Now let's solve this for n equal to 3. Or let us solve this for n equal to 1. Okay, then I will just give the final conclusion. For n equal to 1. So delta of x, what would be the answer? X plus h minus x equal to h. Can you see the pattern between these two? Delta of x and delta square of x square. Can I conclude like this? The delta to the power delta n x to the power n is equal to factorial n into h to the power n. See that here this is factorial 1 h to the power 1. This is factorial 2 h square. If you do delta cube h cube, you will find 6 into h cube. Okay, so this is the formula. It was discussed in the class. Kindly check it. So now, what is the formula? What is the formula of delta to the power n of this term? Okay, and another thing, suppose okay, so there will be many terms over here. So let's just do one small calculation. Suppose you need to find delta square of x square plus x. We know that this is a linear operator, so we can take this delta square of x square plus delta square of x. Hmm. Now we have already found that delta of x equal to h, which is a constant. So delta square of x is what? Delta square of x is 0, right? So that means, so if I have a term if I have a term whose order is less than n, so that term will automatically be 0, right? So here there will be many terms in this expression, but the highest term that contains it will be a, b, c, d, x to the power 4, x to the power 3, 7, plus 2, 9, plus 1, 10. It will be x to the power 10. A, b, c, d, x to the power 10. Okay. So if I just do delta to the power 10 of this term, it will be a, b, c, d. Those will be constant times h to the power 10 into factorial of 10. Okay. Now, if I assume that if my h is equal to 1, you will get that ABCD factorial 10 is your correct answer. Okay, I hope this is clear. Okay. Now, this question, it says that find the interpolating polynomial fx equal to x cube, find passing through the points 1, 1, 2, 8, 327 and 464. On the interval 1, 4, the value of an upper bound for the interpolation error is. You need to find the error. Okay, but I hope that you can see the pattern here. Let us just do this. If 1, 2, 3, 1, 2, 3, 4, that is 1, 8, 27, 64. Can you see the pattern? That fx equal to x cube. This is an exact answer. You can build a table if you like. So it will be delta f, we will be 7, 19, and what is 64 minus 27? It is 37, right? Delta square f, it will be 12, 12, right? Delta cube f is 0. So what? So here, what is the you need to? So you need to get the polynomial, and what is your p? P equal to x minus x naught. X naught here I am treating. This is my x naught 1 divided by divided by 1, because my h equal to 1 here. So p equal to x minus 1. So what is the polynomial? The fitting polynomial px equal to f naught. F naught is my 1 plus uh, p into delta f naught. Here my p is x minus 1. Delta f naught is 7 plus uh, p into p minus 1 by factorial 2 delta square f. So x minus 1, x minus 2 by factorial 2 into 12 plus something into plus some expression into delta cube f, plus my delta cube f is 0, so I don't bother about that. Okay? Because this, no, sorry, not probably making a mistake in the calculation. Let us just check. Should be particle formula 64, 1, 8, 27, 64, 7, 19, this is 37, 12, 2 plus 7x minus 7 plus 6 into x squared minus 3x plus 2. Just a minute. So, 7, so it will be first one 7, it's 19, 27, 7. So the delta square in 0. Okay, so I will talk about this problem in the next week. I thought I will solve it in another method, but it comes out that here delta cube f is coming equal to 0. So I will talk about this interpolation error in the next week. Okay, so let's move on with the next question, question 11. Uh, so every function of fx. Uh, yes, Anjali. Hello. I'm not able to hear you. Hello. Am I making mistake in the formula somewhere? If you find some mistake, please share with me. Okay, then I can do the problem this way. Okay. So I can't hear you actually. Hello. Sorry, you are. So can you just type? You are not audible at all. Okay, so let's continue with this question 11. So Newton's backward interpolation formula is useful when the value of fx is needed near the end of the given set of table. Yeah, that is correct, because when you are given a set of data and suppose your x is 1, 2, 3, 4, and you need to calculate the value at 3.8, then using the Newton's backward formula is useful this time. So this option is correct. So we have done a similar problem like this already. So here there are four data points and four degree polynomial, but actually we can actually fit a polynomial px of x cube, right? So this so here this answer will be correct. So we can fit actually infinite number of polynomials. Okay, we can let's so we can so I am making some mistake in calculating the table, generating the difference table. So one thing we can do very easy. So px, so there are four data points. We need so we will have a plus bx plus cx square plus dx square. We can always assume this kind of function. Okay, and I have total four data points. Okay, so and there are four unknowns a, b, c, and d. We will do some problem related to this in the later in the session. So for this, if you calculate, if you put the value and calculate all those things, you will find a 4 cross 4 matrix. So you will find a 4 cross 4 matrix with A, B, C, and D. On the right hand side, it will be 1, 8, 27, and 64. If you do the calculation, you will find that A equal to B equal to C equal to 0, and your D will be equal to 1. So this Px will be exactly as x to the power q. Okay, if you put the values, you will find that this is exactly the curve. So in this case, your error will be equal to 0. You can always find a polynomial like this. Okay, this is the easiest way. Okay, so yeah, so here you are we are given a data point. So these are some compared to some easier problem. So this is your data set, right? We need to find a value of y at x equal to 5. Right. So let's do the calculation. I will use the Newton's forward difference on y 0, 2, 4, 6, 8, 4, 26, 58, 1, 2, 4, 6, 6. Delta y. So yeah, so calculate the value of p. P is your 5 minus 0, that is x minus x naught. That is x minus x naught divided by 2. So your value of p will be here 2.5. Okay. So now what is the value of delta y? This is 22. 58 minus 26 is, I guess, 32. 112 minus, let me just do the calculators just to make sure I'm not making any mistake. So 26 minus 4 is 22. 58 minus 26 is 32. It is also correct. 112 minus 58 is your 54, and 460 minus, sorry, 466. 466 minus 112. It is 354. 54. Now your delta square y, it will be 10, 22, 300. Delta cube y will be 12, 278. Delta to the power 5y will be equal to 266. Right. So now I just need to put this thing in the formula. Okay. So what will be the result at y5 is equal to y naught. Y naught is 4 plus, just a second, 2.5, that is p into delta y naught 22 plus p into p minus 1 by factorial 2. It will be 2.5 into 1.5 by 2 into 10 plus 2.5 into 1.5 into 0.5 by 6 into 12 delta q y naught plus 2.5 into 1.5 into 0.5 into minus 0.5 by 24 into 266. So I have already done the calculation previously. If you do the calculation, you will get a result of 71.109. So this will be your final result. Again, a similar problem like the last one. So here I need to calculate the value of g 0.2. For value okay, no, here I have calculated based on x not equal to 0. Okay, you can shift it if you want, but taking x not equal to 0 is the easier option, so I have taken that. If you wish, you can do that. You can change the definition of x naught. Then if you change the definition, if this is your x naught, then it will be x minus 1, x minus 2. Just keep those in mind because those also will involve in this calculation. Okay. Okay, now I need to construct a table for I need to construct a difference table for this data set. Okay, just a second. This is a comparatively a very simpler problem. Okay, I am constructing the table here. So your delta G is 9, 9, 9, 9, and delta square G is 0. All of those will be 0. So here what will be the result? G of 0.2. So what is the value of my P? P equal to 0.2 minus 0 by 1 equal to 0.2. So it's so 176 plus P into delta G into 9. So the result will be 177.8. Okay. So this is your answer. Now, so this is an interesting question. So here we are not given any particular value. We are given a range, and we need to calculate here. So first I need to find a value of delta to the power 4 of y naught. So how how can we proceed here? Okay. So one thing we can always do, just just see if we can write like this. So below. So here, so okay, so So here these are the marks distribution and these are the number of students. Okay, and I need to calculate the value delta to the power 4y0. So and the number of students. Suppose my number of students I am defining a y. So below 40, 31 to 40 means below 40 is 31. Below 50, that means the students who are already below 40 will again come in this category, because the students who got suppose 37, 38, that is less than 50, but also those students who got 48, 49, that is also less than 50. So it will be 31 plus 42 equal to 73. For the same reason, below 60, all those students who are less than 40, less than 50 will be also less than 60. That means 73 plus 53 is 126. 73. So okay, so this data should be 51. Right. So this 124 less than 70 is 124 plus 35, 179. Just a moment. Just a moment. So this is an old assignment problem. I have probably written some wrong value. Just a second. Okay, okay. So but it doesn't matter anyway. So so less than 80, that it will be 179 plus 31, that means 210. So total 210 students is here. So let's just check again. 31 plus 12, 42, 73. 73 plus 51 is 124. 124 plus, oh yeah, here I have made a mistake, which is 159 plus 31 is 190. Right. This is 190 students. Now delta y, so I think this idea is clear. Okay. So delta y is 43 minus 42, 51, 35 and 31. Delta square y, it is 9 minus 16 minus 4. Delta cube y is, I have made a mistake. So minus 16 minus 9, it is minus 25. Minus 4 minus 4, this is plus 12. Probably I have made a mistake again. Let me just check. This is 42 correct, 51 correct, 35 and 31, right? And this is 15. So 159 minus 124, this is this value is 42, this value is 51, this value is 31, this value, sorry, this value is 35, this value is 31. Now this value is 9. If I'm making mistakes, please correct me. Huh? This value is minus 16. This value is minus 4. So this value will be minus 25 and this is plus 12. So delta to the power 4y is 12 plus 42. So this is 37. Okay. I may have made a mistake here. Just check this calculation. Okay. But the main idea, the key idea is this. So how to, so here this is, you are provided a range. Now you have to convert it to some number and you need to do the calculation. The main idea is here. I may have made some mistake in this making the table, just check this. All right. Now, now from the previous question, calculate the number of students who got below 55. Now the idea is very simple. Okay, here your x naught. I will just give you the outline of the idea, and you can do the calculation very easily. So the only thing is that you need to find the value of t. So you're here in the second question. My x naught is 40. This is the value of my x naught. This x naught is 40. Your x is 55. Hmm. So this is the value of your x. So what is the value of p? Okay. Now your h is 10. Your h equal to 10. So p equal to 55 minus 40 by 10 is equal to 1.5. So this is your value of p. Now what is your y 55 equal to y naught? That means y at x equal to 40 plus p delta y naught plus p into p minus 1 by 2 delta square y naught plus p into p minus 1 p minus 2 by 6 delta cube of y naught plus p minus 1 p minus 2 p minus 3 by 24 delta to the power 4 of y naught. Okay, so just put the value and do the calculation, you will get your desired answer. Okay, I'm not doing the complete calculation here, so just do it. Just a second. So now question 7, question 17. Okay, so this is an old gate question. This is not exactly. This is partly related to this interpolation problem. Okay, right. So we are given that if the quadrature rule 0 to 3 fx dx equal to alpha f1 plus beta f3 is exact for all polynomials of degree 2 or less, then I need to find the correct choice. Okay. Now the main idea is it is exact. Okay, but my degree of polynomial is less than or equal to 2, and now I need to find the value of the alpha and beta. So this is partly related to the interpolation problem because of this exact thing. So now what I can assume, suppose, so this is true for all polynomials of less than 2. Okay, so I can assume a plus bx plus cx square. I can assume b bx square plus cx, anything I want. But the simplest choice will be fx equal to x square. So this is the easiest choice. Okay. Now let's do that. Now for in this case here f is x square. So that means I will, so integration 0. So integration fx dx is what, x cubed by 3, and it is varying from 0 to 3. So x cubed by 3, 0 to 3 equal to alpha, and here f of 1, that means alpha into 1 plus beta x square, that means x 3 square. which will beta into 9. And this value is 27 by 3 is 9. So alpha plus 9 beta is equal to 9. But this is but here I have two variables, alpha and beta. Okay, and this is only one equation. Now what to do? Now again just read the question statement. This is true for all polynomials less than or equal to 2. That means when fx equal to x, again this is true. Okay, again, so again find the integration. So this will be x square by 2 from 0 to 3 equal to, again f of 1 is 1, so alpha, f of 3 is 3, alpha plus 3 beta, and this will be alpha plus 3 beta, and this is 9 by 2, this is 9 over 9 by 2, and we can do the calculation very easily. It will be 6 beta equal to 9 minus 9 by 2 equal to 9 by 2. So beta equal to 9 by 12 equal to 3 by 4. That means alpha equal to 9 by 2 minus 9 by 4 equal to 9 by 4. So alpha equal to 9 by 4, beta equal to 3 by 4 is the correct answer. Okay, I hope this idea is clear. Okay. Now, this is directly related to the interpolation problem. This is from GATE 2017. Now, so first let's focus on the data point. Okay, then I will try to find the value of this constant, delta, gamma, beta, alpha, and so on. So these are the four constants, and I need to find a value of gamma minus beta. Okay, you will find that in the process we will be able to deduce all those constants. Okay, so again we need to construct a different step. So this is x, and this is your f. I am giving the name f. So minus 1, 0, 1, 2, minus 3, 1, minus 1, minus 3. Delta square f, this value 4, this is minus 2, this is minus 3, so this I think this will go again also minus 2. Am I correct? Just a second. So I am correct. Right. Now delta cube f, okay, minus 6, 0, delta to the power 4f, 0 minus of minus 6, that is plus 6. Now, what is px? First of what is p? X minus x naught. What is x naught? X naught is minus 1. So it will be x plus 1 by h. H is what? 1. So p equal to x plus 1. So f of x plus ph. H is 1. Okay. So it will be f naught plus p times delta f naught. It is going up to delta to the power 4. Okay. Plus p into p minus 1 by 2 delta square f naught plus p into p minus 1 p minus 2 by 6 delta cube of f naught just a moment. Okay, so this is delta f, delta square f, this is delta cube f. Okay, so I just need to stop here. So this is, so now f naught is minus of 3 plus p is x plus 1 times delta f naught into 4 plus, and so x, so p into p minus 1, that means x plus 1 times x by 2 into delta square of f naught into minus 6 plus x plus 1 x x minus 1 by 6 into 6. So what will be the result? The result will be minus 3 plus 4x plus 1 minus 3 x into x plus 1 plus x into x plus 1 x minus 1. So this is the final expression. Now compare with these values. Okay, the constant. So delta, delta is the constant term. So here the constant term is minus 3. So delta equal to minus 3. Gamma into x plus 1. So gamma equal to 4. Beta into x plus 1. Beta equal to minus 3. And alpha x plus 1 x minus 1. So alpha equal to 1. And in the question, it is told that you need to find the value of gamma minus beta. So what is gamma minus beta? Gamma minus beta is equal to 7. So this is your final answer. Okay. So let me first solve this question, because this question is 21. This is related to this question. Okay. After that, I will solve 19 and 20. Okay. So I will be back in 2 minutes. Just a moment. Okay. So let's proceed with the calculation. So this is the, so here you are given, again I just need to follow the same thing. I have to construct the different step. So x and p. Okay. Here it is told that I need to find a value of p 5 by 2. So 0, 1, 2, 3. 2, 3, again 2, 5. So your delta p, the delta p is 1, minus 1, 3. Delta square p minus 2, 4. And delta cube p is your 6. Okay. So again I need to I need to find a value of p 5 by 2. Okay. In that case I am taking this as my x naught. Hmm. So what is my 5 by 2? So what is my p? P equal to x minus x naught by h. My h is 1. So this is 5 by 2 minus 0 by 1 equal to 2.5. So my value, so my p is 2.5. Okay. So let's calculate the result. So p of 5 by 2 is equal to p naught. P naught is 2 plus p p into delta p, that is 1. Okay, okay, sorry. First, let me calculate. First, let me find the value of a naught, a1, a0, a1, a2, a3. First, construct a polynomial. Then I will just substitute x equal to 5 by 2. Okay. So, what will be the value of px? Px will be 2 plus. I have already got that p equal to 5 by 2 plus 5 by 2 into x minus x naught, right? So plus 5 by 2 into x plus p into p minus 1 by factorial 2. 5 by 2 into 3 by 2 by 2 into x. Oh, sorry. I'm making mistakes. So f of x0 plus ph. First, let me write the formula. F naught plus p delta f naught p into p minus 1 by 2 delta square f naught plus p into p minus 1 p minus 2 by 6 delta cube f naught. Yeah. Now let's substitute, just substitute the value. So now for any general x, what will be the value of p? P will be x minus x naught. X naught is 0 by 1, so p equal to x for any general x. So what will be the result? So f of x naught plus ph equal to f of x equal to f naught. So first value is 2. So f naught and p naught, f and p are just the same. Huh? Times p into delta f naught. Here it means x into delta, that means 1 plus x into x minus 1 by 2 into delta square of x naught is into minus 2 plus p into, sorry, x into x minus 1 x minus 2 by 6 into 6. So the result is 2 plus x into x minus 1 plus x into x minus 1 x minus 2. So what will be the value? So a not equal to 2, a1 equal to 1, a2 equal to minus 1, a3 equal to again 1. Now you just need to substitute x equal to 5 by 2 in this place, and you will get 2 plus 5 by 2 minus 5 by 2 into 3 by 2 plus 5 by 2 into 3 by 2 to 5 by 2 minus into 1 by 2. So you will finally receive the result 21 by 8. Okay, if you do the complete calculation. Okay. So now let us now solve the last two problems, that is 19 and 20. Again, these are related to the interpolation idea. Okay, so let's first solve question number 19. So here you are told that f is a 3 times continuously differentiable real valued function on 0 to 5, such that its third derivative f triple prime x, that means g cube f dx cube, is equal to 1 by 100. Px is a polynomial of degree less than or equal to 2, such that f1 equal to p1, f2 equal to p2, and f3 equal to p3. Then what is the value of f4 minus p4? Absolute value of f4 minus p4. So I will give you the outline of the answer. So first of all, f of x is equal, I am assuming this as x triple. So f triple prime x equal to 1 by 100. So if I assume that it is, so if I just assume that f x equal to a into x cube, right? So f prime x square, f double prime x equal to 6ax, f triple prime x equal to 6 of a. So 6a equal to 1 by 100. Here a equal to 1 by 600. So I can assume that fx equal to x cube by 600. I can I can always assume this kind of thing. Now again I have to do one assumption that px is a polynomial of degree less than or equal to 2. Hmm. So I can assume that px equal to ax square plus bx plus c. Now we are given some information. We are given three equations and I have three unknowns. The equations are f1 equal to p1. So a plus b plus c equal to 1 by 600. This is equation number 1. Again f2 equal to p2, that means 4a plus 2b plus c equal to 8 by 600. This is equation 2. And f3 is equal to p3. So this is so 3. So 3 square. So this is 9a plus 3b plus c is equal to x cube by 600, that means 27 by 600, which is the equation 3. Now you need to solve the value of a, b and c from these three equations. Okay, so let's calculate that. So I don't have space here, so I am writing at the end. So first equation is a plus b plus c equal to 1 by 600. Then 4a plus 2b plus c equal to 8 by 600. And finally 9a plus 3b plus c 27 by 600. Okay, so these three are the equations. So how to proceed? So yeah, so just a second, let's just calculate it online. A plus b plus c. So I can write a matrix equation like this. You are already familiar with this kind of thing. 4 2 1 9 3 1 A B C 1 by 600, 8 by 600 and 27 by 600. Okay, so what you need to do, so I think I will give you the outline. You just need to calculate the value of a, b and c. Okay, you will find some value. And so when you got already a b c, then you know what will be the value of the expression, right? what is what is px, and then you need to find the value of f4 minus p4. So you just need to find the value f4 minus p4. You already know the expression of f4, right? And you just need to calculate the p and put the value 4. Now there is one interesting thing that I should mention about this question. Okay, so in that question, so what was that? F1 equal to p1, f2 equal to p2, and f3 equal to p3. But f4 is not equal to p4. If you calculate that, you will find that f4 is not equal to p4. Okay, you will find some finite value in that case if you do the complete solution. Now what is happening here? Now if I plot this thing, this is your suppose fx equal to x cube solution, something like that, maybe. Yeah, so it is something. So this is your fx equal to x cube solution, and your tx solution, it is agreeing at some value. So this double this x equal to 1, this is x equal to 2, this is x equal to 3. So it may be some value, so it is approximately agreeing this solution. But it is diverging when x is increasing. Similar thing happens in case of exponential function, exp of x. Similar kind of thing. We are not sure that all the points, suppose it is that f of x equal to p of x for all x less than equal to 3. We are not sure about that. Okay. But as the value of it is increasing, they do not agree with each other. This is this is we can this is not true. This is not true because nothing is given, nothing, no information like that is given in the question. It is only agreeing at the discrete points, that x equal to 1, x equal to 2, x equal to 3. But a similar kind of thing happens in case of exponential function. So what is the series expansion? This is 1 plus x square by 2 plus x cube by 6 plus dot dot dot. So in my first lecture, I have shown so that if we so this is 2 e to the power x. So this is your e to the power x function. No, it will be much steeper. It will be something like that. So this is approximately equal to 1 when x is very close to 0. It is approximately 1 plus x when x is slightly large but not sufficiently large. Okay. Then after then for a slightly larger value of x, it will agree with 1 plus x square. So this is e to the power x equal to 1. This is e to the power x equal to 1 plus x. This is e to the power x equal to 1 plus x square by 2. Okay. But as the value of x keeps on increasing, then we need to just add the terms. Okay. Not after a certain limit, this is a quadratic polynomial. It will not agree. It will be something like that, but exponential function will just go up. Okay. A similar kind of thing is happening, not exactly because we only have the discrete data points, but as the value of x increasing, x cube function is not agreeing with the ax square plus bx plus c, because this will go up much faster compared to this solution. Okay, so this question is somehow telling us that fact. All right, please do the complete calculation. Okay, now let us move on to the last question. Okay, this question 20. So here, so this is true for all polynomials of degree less than or equal to 3. Okay, this minus 1 to 1 fx dx equal to f alpha plus gamma f beta. This is true for all in less than or equal to 3. Then I need to calculate this value, gamma plus 3 alpha square plus beta square plus alpha cube plus beta cube. So how to do that? So first, assume case 1. Can I do the calculation here completely? I guess not. Okay. So fx equal to x cube. If I don't have the space, then I will just go to the end and continue there. Okay. So when fx equal to x cube, so minus 1 to 1 x cube dx. So from the basic integration thing, you know that this is this is an odd function, because minus x of whole cube equal to minus x cube. Okay. Odd functions are f of minus x equal to minus of fx. So it agrees with the idea, and this when minus 1 minus a to a fx dx, when fx is odd, this is 0, and when fx is even, I will use both the ideas. So I am just stating it here. A to A fx dx equal to 2 times 0 to A fx dx. This is just elementary finite integration idea. Okay, definite integration idea. Okay, so I don't have space here, so now I am going at the end. So my first function is x cube dx. Okay, because this is true for all polynomials of order less than or equal to 3. Right. So this is question number 20. So fx equal to x cube. So minus 1 to 1 x cube dx. This is an odd function. So this value equal to 0. And my approximation f alpha plus gamma f beta. F alpha plus gamma f beta. So when fx equal to x cube, so then so alpha cube plus gamma beta cube is equal to 0. This is my equation number 1. Now when fx equal to x square, so minus 1 to 1, this is an even function. X square dx 2 is 2 times 0 to 1 x square dx 2x cube by 3 0 to 1 equal to 2 by 3. Now, so it will be alpha square plus gamma beta square equal to 2 by 3. This is the second equation. But there are three unknowns. Alpha, gamma, beta. Okay. So let's go down to another order. If x equal to x. Hmm? So it is minus 1 to 1 x dx. See that this is again also an odd function. So it is 0. So alpha plus gamma beta equal to 0. 3. So one thing you can do, that you can solve the problem from here. You don't need anything else. Alpha, gamma, beta, 3 equations here. But I don't want to solve this in this manner. Okay? Because in the question I am told that I need to find the expression. What is the expression? Yeah. I need to find this expression. Let's write down the expression here. I need to find gamma plus 3 times alpha square plus beta square plus alpha cube plus beta cube. Let's just check that. Gamma plus 3 alpha square plus beta square plus alpha cube plus beta cube. Yeah, right. Okay. Now I also have one more information. This is true for all polynomials less than or equal to 3. That means it will be true for n equal to 0 as well. So when fx equal to 1, this will be 1 minus 1 to 1 x dx equal to, sorry, minus 1 to 1 just dx. So 2 into 0 to 1 dx is equal to 2, and it will be equal to 1 plus gamma, because f of alpha is 1, f of beta is also 1 constant. It implies that gamma equal to 1. So I have already got the value of gamma. Now I need to find this expression. Okay. Now let us observe these three equations very carefully. So the first equation. So I have gamma equal to 1. Okay. The first equation is alpha cube plus gamma beta cube equal to 0. Second equation, alpha square plus gamma beta square 2 by 3. Third equation, alpha plus gamma beta equal to 0. And I need to find this expression. Copy. I will paste it here. Paste. I need to find this expression. Okay, so how to proceed? So see that in question 3, sorry, in equation 2, let us just multiply it with 3. Then I will get 3 alpha square plus 3 gamma beta square equal to 2. And I have already got the gamma equal to 1. So 3 times alpha square plus beta square equal to 2. So I have already got this expression. So this part already got cleared. Now gamma equal to 1. You see that using this thing makes our job very simple. If x equal to 1. There, then it is instantly giving me gamma equal to 1. So if I put gamma equal to 1 in equation 1, I will get alpha cube plus beta cube equal to 0. So I have also got this part as well. And I have already got that gamma equal to 1. This gamma. So I know everything in this expression. My gamma equal to 1 plus 3 times alpha square plus beta square equal to 2 plus alpha cube plus beta cube equal to 0. So so the final expression is 1 plus 2 plus 0 is equal to 3. So this is your answer. Okay. So let me just go over this problem once again. Just the conceptual idea. So one thing that your equation so so this is some integration, and the polynomial you is getting is exact. The final answer is exact. Okay, that means your the error we are talking about in this interpolation, the error is 0. Okay, this is just like the previous problem where I was making mistake initially, where fx equal to x cube, then the error is 0. This is exactly the same problem. Okay, similar problem. So here your error will be 0. Okay, this exact thing ensures that the error will be 0. So and it will be true for all polynomials less than or equal to 3. So the first choice obviously is fx equal to x cube, and so here this is an odd function, even function, and so the first choice is fx equal to x cube, and it is giving me this expression alpha cube plus gamma beta cube is equal to 0. The second choice is fx equal to x square, and it is giving me this answer alpha square plus gamma beta square equal to 2 by 3. Okay. And the third choice is fx equal to s. It is giving me, so this is actually not necessary in this question because there is no alpha plus beta expression. I can always have a plus find plus alpha plus beta, and it will be again plus 0. No problem. So, but I need this equation because this equation is making my job simple. So minus 1 to 1 dx equal to 2 is equal to 1 plus gamma, because here f alpha equal to 1, if beta is also equal to 1. So this is 1 plus gamma. It gives me back the gamma equal to 1. So yeah, so this expression is alpha cube plus gamma beta cube. It reduces to alpha cube plus beta cube equal to 0 because my gamma equal to 1. This is giving me 3 times alpha square plus beta square equal to 2. So I know this expression, I know this expression, and I know this expression. So the final result is 3. Is 3. Correct answer. Okay. So this is the last question. So let me just do quick recap. Then we will be done for today. So so there are many questions regarding the generation. So in the most of the question we have to formulate the first the difference table. Okay. Remember for the forward difference, the idea is delta f equal to fi plus 1 minus fi. Okay. So kindly calculate the difference table by yourself, because it is possible that I have made some mistake over here, but the main idea is clear. Okay. So so this idea is this first question was about the formal generation of the difference table. Then the second question is from the difference table you need to do some calculation and find the polynomial. Okay. So this is the quadratic polynomial. This is the cubic polynomial, because the data points are 4. Here the data points, we have only 3 data points. Okay. And again, this is an example of the shifted forward difference. I can change my difference of x naught and calculate the thing, calculate the polynomial. Okay. So here you need to, so I have done this problem completely, and I have calculated the value, and I calculated the value of cos hyperbolic x. Okay. This is the expression of cos hyperbolic x. And yeah, so this is the exact answer, and this is the approximate answer. And you can see that these results are very close to each other. Okay, so this that means the interpolation thing is working sufficiently fine. So here I have talked about the Bessel function. So kindly take a look at the last page, or the second last page, to find the plot of the Bessel function. This is related. This is similar to the sine or cosine function in the cylindrical geometry. But anyway, here I need to just find the value of the J naught at x equal to 1.72 using forward and the backward difference. Here I have told that you do not need to calculate the difference table for the backward difference, because all these values are already calculated. Remember that for the backward difference, the formula is, and you will find that all the values are already calculated. Here this will be your x naught, and you can find the corresponding values. You don't need to do the calculation, but you need to change your definition of p, because it will affect the complete calculation. The other things will be exactly similar, like the forward difference technique. So here this is a small MCQ question which you can easily understand. And here I have calculated the expression of these two, tan inverse x and delta square e to the power 3x plus 5. Yeah, so this is an interesting question, this question 9. So remember this formula, and here I have used this formula in this expression, and this is the correct answer. So here I was making some initial mistake, but you can anyway approximate your polynomial like this, and if you do that, you will find that your error will be zero in this question. This is also an easy MCQ question, and we have already done this question previously. Again, there are some few basic questions on the general about the finding the intermediate value using the difference table. This is all, these things are also same. Yeah, so this is also, these four are some interesting questions from previous gate papers. So here this is also a similar question like question 20, where you need to find the expression of alpha and beta. So this exact means error equal to zero, and this is and this I so I have to assume at first fx equal to x. So here I only have two constants. Okay, so only two assumptions will be sufficient. Fx equal to x square and fx equal to x, it will give me this answer. This question is directly related to the interpolation. You need to find here you need to first construct a difference table, and automatically you will get all these constants, and you need to just calculate the value of gamma minus beta. You will find that the value will come as 7. Again, this is also similar. Again, this is also similar kind of problem. This is your fx. So you need to ensure you have to choose fx such that f triple prime of x is 1/100. Okay, and uh, you need to assume a polynomial. Okay, and there are three conditions for the polynomial. You will get three constants a, b, and c, and you need to find f4 minus p4. Kindly do this calculation. Yeah, so I have already talked about this problem. I will not go over. I will not go over it again. Yeah, and this is also similar kind of problem. You need to calculate a difference table, and you will get this constant value automatically, and then you need to find the p of 5/2. Just substitute x equal to 5/2 in the polynomial expression, and you will find this is the answer. Currently, check this. But I'm not sure if it is correct or not. Okay, kindly check it. Yeah, and this is the Bessel function that I was talking about. Yeah. So, so this is for today. Good night. I will share this document and the recorded video with you, and we will meet in the next video.